Before we get down to business, it might be helpful to show you the equipment that we will be using tonight. Here's a general view of the imaging setup, with the telescope in the foreground and the imaging laptop, table and chair set back some distance away. Starting with the telescope, it's a 6-inch Newtonian. It has a native focal ratio of f5, but the addition of a focal reducer brings this down to an effective ratio of f3.4. It has an excellent sturdy focuser that has a locking bolt and a 10:1 reduction focusing knob that makes getting proper focus very easy. The telescope is mounted on a medium-sized equatorial mount which is controlled wirelessly from the imaging laptop by the addition of this Wi-Fi adapter. The mount is not guided in any way. Tracking objects as they move across the sky is left solely to the quality of the mount's right ascension motor and the fact that the mount was very precisely polar aligned when it was set up. That polar alignment occurs in 2 stages. The first stage is to reasonably accurately line up the mount in the north-south direction. This is done by laying down a wooden dowel north-south using a magnetic compass and then centering the mount's tripod legs either side using a plumb line. Finally, the tripod head is leveled before placing the mount on top of it. The second stage takes place after dark, using this polar alignment camera and its associated software. This results in very precise polar alignment. Finally, there is of course the camera. It has a Sony IMX178 CMOS color sensor that delivers an image size of 3040 by 2048 pixels, although, as you will see tonight, we will be using its 2x2 binned mode that gives an image size of 1520 by 1024 pixels. The camera is not cooled, but any hot pixels that it may create are quite easily removed by the use of dark frames. Right, we'll start our little tour this evening. From the star Canopus, I've used it as my focusing star, using the Batonov mask and the software Batonov grabber, and you can see that the software is telling me that the telescope is in focus for the camera, giving me these nice yellow concentric circles. So we'll put the software away. I'll go and remove the mask from the front of the telescope, and we'll move on to our first target. I've created an observing list in SkyTools. I need to connect it to the camera, or rather to the mount.
Telescope connected.
Right, the first target for tonight is the Tarantula Nebula, so we'll slew to that.
Telescope slewing to target. Telescope slew complete.
And there is the Tarantula, not quite centered. I'm using a video mode of 5-second exposures at maximum gain. My camera is set to 2x2 binning, giving a resolution of 1520 by 1024. Let's just center the Tarantula up in the frame, and we'll just move it across a little bit.
Telescope slew complete. Telescope slew complete.
And that's just about right. So I'll get rid of the crosshairs, and now we'll increase the exposure. I'll say 20 seconds, and I'll loop on 20 seconds. And that's not bad. It'll bring the dark point of the histogram up to the bottom of the curves. And reasonably pleasant view at the moment, 20 seconds. Let's go and import a dark frame for, where are we, 30 seconds will do, and we'll do just a little stack of, say, up to 4 exposures. That will get rid of the noise. At this level of exposure we can see the arms here of the spider legs arms, whatever you like to call them. After only 2 exposures we're getting great reduction in the noise level, and in fact I think with 3 we can take a snapshot there, and let's see if we can bring out some of the details using the image capturing programs post capturing adjustments. Just brighten it up a little bit, take the dark point down there and say alright, we'll maybe do that a second time. Found it's best to do things in small stages with curves adjustment. We've washed out the central part now, bringing out the rest of the nebula there. That's alright. And maybe we can add some just standard contrast. It's probably giving us a little... Yes, I suppose so. That's not bad. It gives us a fairly good view of the tarantula. Okay. Right, well, I think we can pass on to the next object. And we'll just clear the decks. The live stack, take off the dark field, set the histogram back to default levels, turn off the looping and go back to video mode, and go to our next target, which is a little spiral galaxy in Antilla.
Telescope slewing to target.
And there I think we have it. It doesn't look like very much at the moment. It's just here. So let's just center that up first of all.
Telescope slew complete. Telescope slew complete.
Right. There it is centered. It's time to beef up the exposure. So we'll set a 2-minute loop. And we'll just have to wait for the 2 minutes to expire to see where to set the black point for the histogram. Right, we're getting close, so let's see what we get. Yep, let's bring those up there. The colour balance is quite nice. So now we'll just have to wait for another 2 minutes just to verify what we have. Because we're using a 2-minute exposure, we should set an appropriate dark field correction. 2 minutes there, that'll do, and enable that. Yes, that's not too bad at all. Okay, we can probably get a better view if we go to full size. Yes, alright, so let's do a stack there, a stack of 3, that'll get rid of the noise from single frames, and we'll just wait again to let that cook. Yep, coming up to the end of the 3rd exposure. Yes, and we have a fairly nice clean background image there, so I think we can see what we can do with that. We'll take a snapshot and let's see, make a couple of curve adjustments. Okay, and maybe another one. Right. And just want to bring the dark point down a bit. Should be alright. Let's bring this one back. Okay, and maybe push the contrast up a bit. Okay, and try that. And there we have a fairly pleasant view of the little spiral galaxy there. Very nice. We'll go to the gem cluster in Carina.
Telescope flew into target.
Right, oh, we don't need the dark frame on, do we? So dark field rather, we'll just disable that. Okay, that's a nice pleasant view. Maybe we can make sure the white balance is alright. Right, now I think maybe upping the exposure just a little, not much, say 10 seconds. And I'll loop on that. Beautiful little cluster there. Right, we need to set the black point on the histogram up to about there. I think it's nicely colour balanced. Yes, and we can begin to see a little bit of the nebulosity that surrounds it, but we'll stay with the cluster for the moment. And let's do a stack of 3 there. It won't take long, 30 seconds. Right, that's a nice clean image there. Take a snapshot of that, and we'll pass on to the next object, which is very close by. It's up over here, I think, and it's the Gabriella Mistral Nebula, and go to NGC 3324, which is the
Telescope slew into target. Telescope slew complete.
Right. And I think this is a 1.5 minute exposure. So let's go back to Tube Sky. Here we'll set 30 seconds and 1 minute, and we should set the black point, dark field correction rather, for 1.5 minutes. Loop on that. Yes, it's looking not too bad at all, so we'll do a little stack of those. You'll probably recognize the profile, supposed profile anyhow, of the Chilean poet, late Chilean poet, Gabriella Mistral. And as I say, this is an outlier of the Eta Carina Nebula, and it always looks to me as if this might be a supernova remnant. And there we are, a stack of 3 exposures, nice clean image. I don't think we need to do very much in the way of enhancements there, but let's take a snapshot and maybe just add a little curve adjustment. Nothing very much. Yes, it's looking good. Yes, and maybe just take out some noise a little bit further. Yes, a nice clean image there. That's a pleasant view. Right, time to pass on to the next target. We'll go to the Eta Carina Nebula. Well, a little bit of it, because it's much too big to fit into a single...
Telescope slew into target. Telescope slew complete.
Now, how shall we frame this? All right, well, let's reasonably framed. Let's go back to tube sky here. For the exposure, I think we'll need 10 seconds. No, maybe 30 seconds. You can set 30-second dark frame. Right. And we'll just bring the come on, there you go. To about there. That's better. The Eta Carina itself is really overexposed, but we get more of the nebula. Alright, let's take a stack of that. Won't take very long. Right, coming up to stack of 3. There we go, nice clean image. Let's take a snapshot of that and see what we can do with that. We won't need to do very much. Let's see if we do just a little curve, nothing very much. And take this one back again like that. Maybe we can just ease that over there a little bit. Right. And maybe another little one. Yes, well, we've really overblown the bit in the middle there, haven't we? Never mind. Okay. Perhaps we could go back one step, take out the last adjustment, and instead put in some little contrast. That's probably better. Yeah. Right. Yes, reasonably nice, good image there. Pump up the brightness a little bit. Yeah. That's a pleasant view. The Keyhole Nebula here. Eta Carina, of course, well overexposed there. And the nebula extends way out on all sides. Okay, time to pass on. And our next target will be the Wishing Well cluster close by.
Telescope slewing to target. Telescope slew complete.
Right, that's looking good. And I think an exposure of 10 seconds is probably about right. Okay, let's do a stack on that. Yes, beautiful cluster there, one of the largest in the sky. Right, I think we can take a snapshot of that for later use and move on to our next target, which is the Lambda Centauri Nebula, commonly known as the Running Chicken Nebula.
Telescope slewing to target.
It's a very large nebula, so we're only going to be able to pick up a bit of it in one frame. Let's set up a 2-minute exposure. Right, coming up to the end of the 2 minutes. Way washed out, of course, but it's pretty nicely colour balanced. So if I put the dark point there, perhaps just a little bit closer in. Oh, and we're doing a 2-minute exposure, aren't we? So we should get a 2-minute dark field. There. Yes, that's getting quite good. Right, fairly nicely framed. So I think we can do a stack there. Do a stack of 3. Of course, we'll just have to wait for that to cook. Now, coming up on the end of the 3rd exposure. Yep. So we'll save that. And let's see, we can probably bring out some detail there by...
So are you alright? Sorry.
Another one maybe. Right. And let's take it down a bit now. There we are. Oh, no, we don't want that, do we? There we go. Yes. That'll do. It's looking quite nice. See the little Bock globules down here. And the next target we go to is everybody's favourite, the jewel box.
Telescope slewing to target.
Fairly nicely colour balanced. Round about there. Yes, it's looking not too bad at all. Nice, lovely garnet coloured star there. Red giant. Okay. Let's do a quick stack. Right, yes, it's looking very nice, very pretty. Maybe we can just get a closer view. Very nice. Right, I'll just go back, get the full frame, and take a snapshot of that. And we can pass on to the next target, which is Centaurus A. Right, put the crosshairs away. This is going to take, let's see, 2 minutes. So, trigger mode, 2 minutes, take out the 10 seconds just to bring it up to about there. Should be alright. And we'll need a 2-minute dark frame. Yes, not bad at all. Right, we'll stack that. Stack of 3 exposures, nice and clean. Let's take a snapshot of that. See if we can make any small adjustment to it. Bring up some, just a very small, nothing very much. There. Yes, I think that's probably okay. Maybe we'll see. You see we've got the dust lane curving round the back there. Let's see if we can bring that up a little bit. That's about right. Okay, maybe a little dark. Yeah. Yes, interesting, Alex, see that? Very interesting. Okay. And we'll go to the next target, which is the Omega Centauri globular cluster.
Telescope slewing to target.
Right, 10-second exposure, I think, for Omega Centauri. Okay, let's take it to about there. Yes, not bad at all. Okay, we can just stack 3 of those. Right, I'll just take a snapshot of that. And perhaps a little tweaking. We'll see. May not be necessary. Yes, I think that's very nice. Okay. Now, assuming it's high enough in the sky, I think it is, we want the next target, which is the southern pinwheel, but M83, the southern pinwheel galaxy.
Telescope slewing to target.
And for this target we want, I think, 1:30 seconds. Let's get an appropriate dark frame. 1:20, 1:40. That'll do. Right. We'll set the point just about there. Tweak it a little bit there. Right. Not bad. Not bad at all. Alright, well, we'll stack that. I think we might look at that in full resolution. Three exposures stacked. Nice clean background. So let's take a snapshot of that. And maybe we could look at it in 100%. And let's see if we can tweak that a bit. We'll do things very gently. Perhaps we can try just bolstering up the red a bit, because I know that there are some red diffuse nebula in the spiral arms. No. It's all very subjective, of course, but looks reasonably good. Okay. Yes, it's a nice sight. Put it back to full frame. Yes, it's a very pretty sight. The southern pinwheel galaxy. Right, on. And the last port of call tonight is the large nebula and associated open cluster in Ara, commonly referred to
to target.
as the Fighting Dragons of Ara. This one's going to need an exposure of 2 minutes. Right, oh, that's way out. So we need to balance that properly. Right. Let's see. Let's do a stack. Maybe I might take the black point back a little bit to about there. And whoopsie. Do a stack of 3 2-minute exposures. And there our stack of 3 exposures is completed. So we'll take a snapshot and apply just a little bit of adjustment. See what we can bring out. Yeah. Okay. Might try just a little, maybe not, we'll see. Bring up the nebula a bit. Yeah, that's right. Just a little bit of contrast. There. That should be alright. Yes, very pleasant. Good shock front over here. Interesting little thing there. I think if we were to magnify that up, first of all, let's push it up there. You can see that it's really a hole in this dark dust cloud here, looking at the bright nebula that's hidden from view. You can see it through this little hole here. Anyway, let's go back to full height. And there we have the targets that I planned for tonight. I hope that you enjoyed our viewing session last night. Here's an overview of the images that we saw. you can see that we have a fairly mixed bag of 5 diffuse nebulae, 3 galaxies, 3 open clusters and 1 globular cluster. Our first target was the Tarantula Nebula. It's located in the Large Magellanic Cloud, which is one of the Milky Way's satellite galaxies. So it's not surprising that it's 160,000 light-years away from us. Since we nevertheless see it quite easily, it must be very big, and indeed at 700 light-years across, it's one of the largest diffuse nebula that we know. The view that we got last night was not too bad, but I've taken the liberty of applying some of Photoshop's more sophisticated post-imaging techniques to the image that we captured, and the result shows that there was a lot more information in that image than we drew out last night. Our next port of call was this spiral galaxy in Antilla. It's about 2/3 the size of the Milky Way and lies some 25 million light-years away from us. It never ceases to surprise me that we can clearly see such detail in immensely far-away objects with just the small-sized amateur equipment that we were using last night. By contrast, at only 9,000 light-years away, the gem cluster in Carina is just about in our own backyard. It's a beautiful cluster containing at least 100 stars, many being blue supergiants. You can see that it also contains a prominent red giant star. If you look closely, you can just see some faint red background glow. Applying some Photoshop adjustments to our captured image clearly shows that the cluster lies amongst some diffuse red emission nebulae, and you can even see the bluish tinge of a reflection nebula just by the top of the cluster. Of course, these details are revealed much more clearly in longer exposure images. The Gabriel Mistral is a red emission nebula. The shock wave that forms the silhouette of the Chilean poet is caused by the blast of ultraviolet waves coming from the young cluster of stars to its left in our image. This Photoshop version shows this more clearly and also brings out the curved outlying part of the Eta Carina Nebula on the left side of the image. Our image of the Eta Carina Nebula itself shows only a small part of this enormous nebula, but we can see the keyhole near the center with overexposed star Eta Carinae to its left. The dark cloud that stretches down from the top right corner blocks our view of the glowing red emission nebula behind it, but you can clearly see many dark dust pillars extending out from it over the red background. The Wishing Well cluster is very large as open clusters go. Indeed, it's so large and bright that it is a naked eye object under good viewing conditions. Our image is interesting, but does not really do it justice. This is one object that is best viewed through an eyepiece. It is middle-aged, being about 300 million years old, so one would expect that it will soon dissipate, astronomically speaking. Whenever I look at this cluster, I fancy that its stars outline a large black arrow, or is it a hammer, pointing leftward in our image. Do you see it? The Lambda Centauri Nebula is commonly called the Running Chicken Nebula, but to see why, you would need a much wider view than is shown here. Indeed, our image shows only a small part of this very large nebula. What we do see is red emission nebula caused by the recombination of hydrogen electrons that have been blasted apart by ultraviolet light emitted by the young cluster of stars near the bottom left of our image. Also to be seen are the small dark Bock globules in front of the star cluster. No doubt they will in due course evolve into new members of the cluster. The Jewel Box is one of the youngest star clusters known, with an estimated age of 14 million years. It contains just over 100 stars, including a beautiful red supergiant framed by blue giants and supergiants that are 15 to 20 times the mass of our Sun. Centaurus A is intriguing. Not quite as big as the Milky Way, its nature is the subject of some debate. It seems that it may have undergone a merger between an elliptical galaxy and a smaller dusty spiral system. The dust lanes in front of the galaxy are hard to miss, but you can also see that they curve around behind the bright central core. Also, they appear to be slightly warped. Only superlatives can be mentioned in the context of Omega Centauri. A naked eye object that looked like a fuzzy star when it was catalogued by Ptolemy in 150 AD. So he gave it a star designation using the Greek letter Omega. It's a globular cluster containing about 10 million stars. But is it a typical globular, or is it the core of a galaxy that has been captured by the Milky Way and stripped of its outer stars? We didn't do too badly last night, but applying Photoshop allows us to get an even better view. Unquestionably, the southern pinwheel is one of the showpieces of the southern skies. Only half the size of the Milky Way, it nevertheless looks large to us because, as galaxies go, it is relatively close. Indeed, it's one of the closest and brightest barred spiral galaxies in our sky. From our near face-on view, you can see its barred spiral nature with sweeping blue arms extending out from the ends of the bar. I think that I overdid the red tint of the galaxy last night, and this photoshopped version better shows the blue spiral arms with red dots of emission nebulae embedded within them. Our last image here shows but a very small part of a large and complex red diffuse nebula in Ara. The whole nebula is given the popular name the Fighting Dragons of Ara because the region around the bright shock front seems to show the opposing heads and bodies of two dragons engaged in battle. All that we can see here is the head and neck of one of the dragons extending upwards from the bottom of the frame and biting its opponent above it. The red shock front seems to be caused by the young open cluster of stars at the upper right. Video astronomy is not to everyone's taste, and it must be admitted that views of some objects, such as bright open clusters like the gem, the wishing well and the jewel box, are better had at the eyepiece where the stars sparkle like gemstones. But for most other deep sky objects like diffuse nebula and galaxies, a little 6-inch telescope needs the power of a camera to reveal the detail and colour that just cannot be seen with an eyepiece.